Have you ever just looked up at the night sky? You're peering into this unimaginably vast theater of space, right? It feels so still, so quiet, but if you were to zoom out and look at an entire galaxy, you wouldn't see stillness at all. You'd see a wildly dynamic, massive system of moving parts. So, how does it all hold together? I mean, think about it. At first glance, a galaxy looks completely chaotic. You've got billions of stars, these massive clouds of gas, just racing through space in all sorts of directions. There are no physical walls keeping them boxed in. Honestly, by all intuitive logic, a system like that should just shatter and scatter into the void. And yet it doesn't. Galaxies hold their beautiful, swirling shapes for billions of years. Why? Well, the secret is actually surprisingly simple. There's no cosmic glue out there. A galaxy is a self-gravitating system that's maintained by one persistent dynamic equation: gravity plus motion equals stability. It's not frozen. What we're really seeing is this profound, enduring balance between an invisible inward pull and continuous outward motion.
Let's start with gravity as the invisible structure and break the myth of the central anchor.
You see, it's really tempting to imagine that a galaxy works just like our solar system, with everything firmly anchored to one super heavy center like the sun. But it doesn't work that way. Instead, picture a massive crowd of people, all standing in a giant circle holding hands. Every single person in that circle feels the tension created by everyone else pulling. A galaxy works exactly the same way. Gravity is this invisible structure spread across the entire collective.
Literally, every bit of mass pulls on every other bit of mass. Gravity isn't just some local force tied to a single point in the middle. It's a shared, distributed network of pulls stretched out across hundreds of thousands of light years. Now let's look at the other side of the coin: motion versus gravity. The dance of balance. So, what would happen if gravity were the absolutely only force acting on all those stars? Well, the whole galaxy would just collapse into a single point. But stars possess immense momentum, and this motion doesn't cancel out gravity. It actually changes how gravity behaves. Because a star has inertia, meaning it naturally resists changing its direction, gravity can't just drag it straight inward. Instead, gravity simply bends its path.
It's incredible when you realize how narrow the survival range really is for a galaxy. If there's too little motion, the whole system collapses inward. If there's too much motion, the stars just escape the gravitational grip and fly off into deep space. But right there in the sweet spot, you have balanced motion, which gives us a stable galaxy. It's a lot like spinning a ball on a string. Spin it too slow, it falls. Spin it too fast, and the string snaps. Galaxies are sitting in this perfect controlled tension.
And this perfect tension creates what we call an orbit. Think of an orbit as a fall that just keeps missing the center. Imagine throwing a ball off a cliff so incredibly fast that as gravity pulls it down, the surface of the planet actually curves away beneath it. The ball just keeps falling, forever, around the center. That perpetual, controlled fall, that's the daily life of every single star in a galaxy. But keep in mind, a galaxy isn't just a rigid wheel spinning at one uniform speed. It's actually a complex system of local balances. A star hovering near the dense center feels a much stronger gravitational pull, so it has to move a lot faster to avoid collapsing inward. Meanwhile, a star way out on the sparse outer edge moves at a completely different rhythm. It's an unbelievably highly coordinated environment.
Which brings us to the hidden role of dark matter, the weight we cannot see.
Here's the crazy part. When astronomers actually measure the speeds of these orbiting stars, a massive problem pops up. The math just doesn't work. If we only count the visible stars, galaxies simply don't have enough mass to hold themselves together. They should fly apart. This introduces a critical hidden player: dark matter. You can think of it simply as hidden mass that provides the necessary extra gravitational pull to keep the galaxy intact. It's kind of like feeling the heavy heft of a packed backpack without actually seeing what's inside. We know it's there entirely because of its immense gravitational effect. Together, all those visible stars and that invisible dark matter create what's known as a gravitational well. It's basically an energy valley. Visualize the galaxy as this incredibly wide, deep bowl made entirely of gravity. Stars are racing around inside this bowl, but thanks to all that combined mass, the bowl is just deep enough that very few stars ever manage to gather the sheer speed required to climb out and escape over the edge. So let's pull this all together and look at the enduring cosmic balance, stability through continuous motion. It's really easy to picture a galaxy as this fragile, static glass sculpture just hanging silently in the void. But a way better comparison is a massive hurricane or a whirlpool. All the individual components are constantly moving at truly terrifying speeds. Yet, the overall structure, that beautiful spiral pattern, persists because the internal forces are continually feeding it.
Now, one of the key forces preventing that giant cosmic storm from just collapsing in on itself is angular momentum. This is rotational motion that naturally resists being squeezed. Think of an ice skater spinning fast with their arms outstretched. The organized spinning motion of the galaxy naturally pushes back against a simple straight inward collapse.
And there it is. Our cosmic mechanism is complete. Gravity isn't just in the center. It's distributed absolutely everywhere. Motion doesn't destroy the system. It bends those paths into endless stable orbits. Hidden mass acts as an unseen anchor, making the inward pull even stronger. And most importantly, stability in the cosmos doesn't mean being frozen in place. Just like a flowing river holding its course, stability means constantly returning to a workable pattern over billions of years.
It's like the quote says, "A galaxy is a living balance of inward pull and ongoing motion. Gravity prevents escape. Motion prevents collapse. And that dynamic balance creates the galaxy." When you look up at the night sky now, you're not just seeing a static, motionless image. You are witnessing an active, magnificent cosmic machine diagnosing and balancing its own massive forces every single second. Once you truly wrap your head around that, the universe just feels different, doesn't it? Which leaves us with one incredibly awe-inspiring question to think about. How does a wildly moving system of this unimaginable scale constantly and effortlessly keep finding this perfect balance between motion and gravity across the eons?